Hello everyone, how's it going? This week's lecture is going to be a little bit different. You might be able to tell given that I'm wearing a hard hat and high vis, but I'm actually on site in Queensland at an installation that me and Alex have recently been developing through our company's Special Design Research Studio. And this project is about two media facades. There's a really big one here and this massive one over here. I want to walk you through a little bit of what it's like to work on a project as a designer. And in this project, for this class, we specifically built this entire visualization in P5.js. So what you can see behind me is a transparent media facade. And this means that the LEDs have little gaps in between them, and that's so you can see through the screen at nighttime. It's a design choice that the architects made, and it's an interesting kind of screen to work on because it kind of changed the way that we approach designing for it. Specifically, the client requested interactivity for this sketch. So we were focused on using pose estimation. That's when you actually detect a person using machine learning. ML5, a P5.js library, actually has pose estimation built into it. So it was really handy for us. And that's exactly what we used for this visualization. Now, this visualization has three different sketches. The three different sketches are designed to interact with people in different ways. And so what I want to talk to you about is exactly how you approach designing for a large-scale interface like this. So the way that we actually capture the pose is by using IP cameras. These little guys here. IP cameras are a really quick and efficient way of capturing video. And now that IP cameras come in as good a quality as 4K, we can actually do really big scale detection. So here we can see real-time pose estimation at work. It's capturing my pose. This kind of technology wasn't possible very recently. We used to have to use something called the Microsoft Kinect before this, and it used a completely different kind of system. It was both much more accurate, but much more finicky. It required infrared light to operate. Pose estimation is significantly better, but as you can see, sometimes it makes more mistakes. So the first thing you really need to think about when designing for a scale like this is how big people are going to be in comparison to the actual interface. The interface is huge and people are tiny compared to it. So you've really got to think about the kinds of movements that are going to make sense on a screen this size. This was one of the hardest challenges, actually getting this right for this project, and it meant coming here a couple of times to get it right. When interacting with a screen like this, I like to talk about the area that people interact with the screen as the stage, and we have to design the stage accordingly. How big is the stage going to be? Where is the stage going to be itself? Should we put it far away or near? Will people be able to be drawn in, or will they be pushed away by where the level of interactivity actually is? These are the kinds of considerations you need to be thinking through when designing for a media facade. Sometimes people call the stage that you actually interact with a media facade or any public-facing technology as the proximity in which you interact with it. And different kinds of proximities are for different kinds of interactions. I'd say the further away you are from an object, the bigger the gesture needs to be. And in this case, pose estimation works really well for big gestures. So we're mainly focused on people actually moving in front of the screen rather than little interactions like waving their hands. So, some details about this project. We're actually working for the LED manufacturer, the people that bring the LEDs in from China. Most LEDs in the world are manufactured in Shenzhen, and I've been to visit a couple times and it's crazy. This screen, a transparent screen, requires a lot of power to drive it. And so you have to work with professionals who know about these kinds of things. I'm certainly no electrician, but what is required is some experience in both networking as well as creative technologies. How do we actually build a stack that works like this? This is a web browser. This is actually Chrome running in Windows, but we had to build it in such a way that it would always turn on, it would never fail, and it would always have redundancy built into it. These are the kind of boring aspects of building a technology that actually are really important to a client's satisfaction. So how can you think about the proximity of people to your sketch or work in this class? They're likely going to be sitting in front of a computer, and that actually constrains down the kinds of interactions you're going to be thinking about when creating real-time interactive artworks. Think through this as one of the affordances of your design in the assessment 4 and 5. How do people actually interact with your work? Is it with the keyboard and mouse? Is it through the camera? And what affordances are connected to these different kinds of modalities?